So again, we are practicing some of the stuff that we've already done, sort of taking it to another level, a little bit more difficult. You might be working with angles that are very big, like 4,300 degrees. What quadrant is that in? Well, one of the ways that we could figure that out is thinking about reference angles and coterminal angles. But if you had 4,300 degrees and you had a calculator, you could divide it by 360 and find out that this is 11.94 around. Yes. Ooh, I could hypnotize you guys. Yeah. You go around 11 times, and then does it make sense that the 0.94, so like 1, 2, 3, 4, imagine going all the way around 11 times, that's not, but we'll pretend it is. And then 0.94, this would be a quarter, this is halfway around, this is 3/4, 0.94 is going to end up in quadrant 4, okay? But this will sometimes be a non-calculator question. If this was a non-calculator question, I would have to figure out, well, what is coterminal with 3,000 or 4,300? And remember, you can find a coterminal angle by subtracting or adding 360 degrees. So what I would probably do for mental math purposes, I would start with 4,300 degrees. I would probably subtract 360 degrees 10 times, because the mental math is pretty easy. Okay? If I did that, I would be left with 700 degrees. And so we could say that 700 degrees is coterminal with 4,300. And then I would probably just subtract 360 degrees again and get 340 degrees. And I could also say that 4,300 degrees is coterminal with 340 degrees. And as soon as I get one in the first time around, is it pretty easy to see that 340 degrees is in quadrant 4? Okay, so that would be a non-calculator way. If you have your calculator, you could just divide and find out how many full rotations and then what decimal. I always get worried on shortened period days that we have to do extra stuff. So it's actually not bad that we accidentally forgot announcements. They're on YouTube later, you can just find them somewhere. I'm sure that's #1 on your priority list right now. Okay. Now in radians, we can do the same idea. If you had a calculator, you could just go and divide it by 2 pi, but these are normally going to be non-calculator questions. So if you had something like -23 pi over 6, there are some things that are going to be really nice in radians. First of all, according to your pi plate, this is going to be coterminal with one of your pi over 6 families. So I know that this is either going to be coterminal with pi over 6, 5 pi over 6, 7 pi over 6, or 11 pi over 6. I just need to find out which quadrant it's in. And the strategy that I like to use with radians is to take the number, which is the 23 over 6, and change it to a mixed fraction. Is everybody okay with changing -23 over 6? I'll put the pi there. That would equal -3, which would get me to 18, right? And -3 5/6 pi. And now we're going to be thinking in terms of pi. Thinking in terms of pi, on angles in standard position, pi is halfway around. So every time you have a whole number, you're going halfway around. This angle is negative, so we would go 1 pi, negative 2 pi, negative 3 pi would end on the negative x-axis. And then we need to go, so we've done the negative 3, we also have to keep going and do 5/6 more. Can you see that that 5/6 is more than half? So it's going to end in quadrant 1. It's going to be coterminal with pi over 6. So we use the whole number to find out where you're going to be, on the positive x-axis or the negative x-axis. Then you'll use the fraction to see, do you go over halfway or not, to the next one. You want to do another one just for practice? Okay, let's do 21 pi over 4. This would be as a mixed fraction 5 1/4. And you're very quickly going to see a pattern that if it says 5, right? Well, here's my pi. This would be 1. All the way around is 2. This would be 3. This would be 4. 5 is going to end on the negative x-axis. Does it make sense that any odd number is going to end on the negative x-axis? Any positive, like this is 0, all the way around is 2 pi, twice around is 4 pi, 3 times around is 6 pi. If it's an even number, you're going to be on the positive x-axis, odd numbers on the negative x-axis. So the fact that I have 5 1/4, the 5 will get me here, pi, then 3 pi, coterminal with 5 pi. The 5 will get me here, and an extra quarter is less than half. It'll end in quadrant 3. And this is the beautiful thing about radians, is then you automatically know that 21 pi over 4 is coterminal with 5 pi over 4. And because you have your circle, you can also do all sorts of math. I could ask you, what is cos of 21 pi over 4? And you'd be like, oh, that's in quadrant 3. It's part of my pi over 4 family. It's going to be negative root 2 over 2. That's why we memorize that pi plate, so we can do mental math with these quickly. That'll take some practice, and we'll get better at it as we go. So, how do we practice this? I have a sheet for practicing, so you can do lots of mental math. And we'll do some of them together to get started. So what I want you to do on this sheet it has 2 assignments. We'll do a couple of questions with assignment 1, then a couple of questions with assignment 2. Assignment 1, and this is just for you, it's just for practice. What we're going to do is we are going to take the 13 pi over 6, and we are going to write what it's coterminal with. And the way that we're going to do that is we're going to take our 13 pi over 6, we're going to write it as a mixed fraction, and that mixed fraction is quickly going to tell us which quadrant it's in. Can you see how the 2 and 1/6 tells me it's in quadrant 1? I'm going in the positive direction. The 2 is going to end here, all the way around, okay? And the 1/6, here's a diagram of what's happening. We're starting at 0. All the way around is 2 pi. So the 2 means that I've gone all the way to here, and then I need to go 1/6 more. So what we're going to write for assignment 1 is that 13 pi over 6 is coterminal with pi over 6. And what the assignment is trying to say here is locate the angles, stating your answer in terms of the angle that falls in the first positive revolution. In other words, what is it coterminal with if you went the first time around in the positive direction? So we'll do a couple of these together. Number 2, 19 pi over 6, which is equal to 3 and 1/6 pi, is coterminal with okay. Can you see the 3 will be here because it's an odd number? And we're going in the positive direction, so we're going around in this direction. 1/6 will end in quadrant 3. What is your pi over 6 family member in quadrant 3? 7 pi over 6. And this is where it's kind of nice. If you know in quadrant 3, it's always 1 more than your denominator. Number 3. If I had 19 pi over 4, as a mixed fraction, this would be 4 3/4 pi. Okay. Can you see that that's in quadrant 2? Because 4 would end here. Once, twice around, 3, 4, and then if you go 3/4, that's going to end in quadrant 2. So we can write that this is coterminal with what's our pi over 4 family in quadrant 2? 3 pi over 4. So the mixed fraction lets us quickly find out what quadrant it's in. And then it's easy to say what it's coterminal with, because you just have to think about your unit circle to find that. Especially when you have big numbers like 101 pi over 4. That's 25 1/4. 25 is odd number. I'm going to hear a quarter more. It's going to be in quadrant 3. You can quickly find out what quadrant it's in. Okay? So for assignment 1, you're just trying to find out what it's coterminal with. You're trying to find out what quadrant it's in and what it's coterminal with. Then assignment 2, it actually wants you to, for the ones that just have the angles, to actually write the coordinates. So if I were to, in question 1, write the coordinates, I'd be like, oh, I know that at pi over 6 is √3/2, 1/2 from here. Pi over 6, what are my coordinates? √3/2, 1/2. For the second one, 7 pi over 6. It's also going to be root 3 over 2 and 1/2, but they'll both be negative because it's in quadrant 3. And for question 3, the coordinates would be, well, pi over 4 family is both root 2 over 2, root 2 over 2, but the x coordinate is negative, and the y coordinate is positive. So it's important to see which quadrant it's in. Now, for your test and for the exam, they give you a tiny little circle at the start. Usually students just fill in quadrant 1, and then they can use that when they're answering questions like these to be like, oh, I can quickly figure it out from my unit circle. Okay. One thing that I would encourage is after you're memorizing it for tomorrow's quiz, every time you answer a question, try to do it from your head first, and then check your circle to see if you're right. So this assignment 1, first of all, you're just going through all the angles and ignoring sine and cos if it says that, and just trying to find out what it's coterminal with. Then assignment 2, which you can, if you want to do them simultaneously, you can. Then once you get to question 9, you're going to figure out, okay, this is in quadrant 4 because it's negative pi over 4. Sine of pi over 4 is root 2 over 2, but negative in quadrant 4, so the answer to this one is negative root 2 over 2. Sine of negative 4 pi, that's my axes family. Sine is your y coordinate. The y coordinate is 0, so you figure out each of these from your pi. Okay? All right. So now let's do some mental math with your pi plate, and I'll show you how I find doing the mental math the easiest. Okay? For the most part, I only use quadrant 1 and the CAS rule. So if I want to find out sine of 7 pi over 6, I would first of all say that's part of my pi over 6 family. And from quadrant 1, I know that pi over 6 for sine, which is the y coordinate, is always a half. So I know this is going to equal a half, but then I have to decide, is it going to be positive a half or negative a half? Well, 7 pi over 6 is in quadrant 3. According to my CATS rule, sine is negative in quadrant 3. So that means sine of 7 pi over 6 is negative a half. Now this is one that's listed, so you could also just look at 7 pi over 6 and look at your y coordinate and see negative a half that way. But the idea will be, see the family, know the family's value from quadrant 1, and then use the quadrant to determine if it's positive or negative. I see the family, pi over 3 family. I see the quadrant, quadrant 2. So then if I'm figuring out tan of 2 pi over 3, I use my strategy of, oh, pi over 3 is just going to be root 3. And then in quadrant 2, according to my CAS rule, tan should be negative. So now we can figure out all of these mental math practicing from our pi. And you see the family is super easy to see in radians. Not always to see in as easy to see in degrees. But my family here is the pi over 4 family. What quadrant is 7 pi over 4 in? Quadrant 4. Is cos positive or negative in quadrant 4? Right, CAS rule. Quadrant 4 is going to be positive. So Again, from my quadrant 1, I know the pi over 4 is root 2 over 2, because my x coordinate is root 2 over 2. And then I just use the other quadrants to find out if it's positive or negative. We could also do mental math with secant, cotangent, and cosecant. If you have one of the reciprocal ones, off to the side, you'll first figure out what cos is, because cos is the reciprocal of secant. Without writing it down, can you see this is part of the pi over 4 family? Can you see that it's in quadrant 4? Cos of negative pi over 4 is root 2 over 2, or 1 over root 2. Those are two different ways you can write it. So then if the question asked you to find secant of negative pi over 4, you could either write 2 over root 2 or root 2 over 1. It's important to be able to recognize that these are the same, right? We got 1 over root 2 from our special triangle, and then we rationalize the denominator to get the root 2 over 2. But when you flip it, isn't the 1 over root 2 nicer to flip? Because now you have a root 2 on the bottom of the other one. So, and you have to recognize both, because it'll often happen in a multiple choice question. They'll give you one form or the other. Cotangent. So first, I would figure out the same thing with tangent. Negative 11 pi over 6. Can you see that it's the pi over 6 family? Now, negative 11 pi over 6, we're going around in this direction. If I know 11 pi over 6 is in the 4th quadrant in the positive direction, can you see if you went 4 quadrants in the negative direction, it's going to be in quadrant 1. Now we usually write root 3 over 3, but remember that that's the same as 1 over the square root of 3. So when you do cotangent, it would be fine if you wrote your answer like this, or like that. So the angle doesn't change. Notice that we have 11 pi over 6, negative 11 pi over 6. The angles don't change, but the ratio does get flipped. So again, I have cosecant. So off to the side, I would figure out the same thing with sine. I find the axes family is just easiest to think about where it is. Axes family negative pi over 2 is going to be down here, right? In the negative, start here, in the negative direction, go down here. Sine is your y coordinate. So sine of negative pi over 2 is negative 1. And so cosecant will be 1 over negative 1, which is just still negative 1. But it's still the reciprocal. Again, it's the answer that gets flipped, not the angle. How does the exam like to ask these questions? The exam likes to ask these questions usually 3 at a time. 3 coterminal angles at a time, and then make you do some simple arithmetic with them. Okay? I'm going to show you the work that I kind of would expect for this. Okay, and I'm going to color code it. I'm going to expect you put a number in for secant 11 pi over 3. I'll do that in blue, green. Cos, I'll do in blue. And tangent, I'll put a number in purple. Then off to the side, I'll do sort of my work. But right underneath, I need to put a number in for each of those. So first, if I want to find secant of 11 pi over 3, I would first figure out cos of 11 pi over 3. This is pi over 3 family. So sometimes when we write the family, we can write it as a reference angle. The reference angle is pi over 3. That's my family. 11 pi over 3 as a mixed fraction is 3 2/3 pi. What quadrant is 3 2/3 pi going to be? Again, we're going in the positive direction. This is pi, this is 2 pi. 3 pi would be here, so we're going to be, the 3 would mean we're at the negative x-axis, and then going another 2/3 more, 1, 2, 3, and 2/3 more. I know that I'm in quadrant 4. Quadrant 4 tells me this is going to be positive. You don't have to write the positive sign there, but I wrote it there just so that I make sure I check, I know that it's positive. Cos of my pi over 3 family is always a half. If you look at quadrant 1, cos is your x coordinate at pi over 3 is a half. And so, secant of 11 pi over 3 will be 2 over 1. Okay? And on the exam, they're just going to check what number you put in there. Do you have the right fraction with the right sign? Positive 2 over 1. And that would be worth 1 mark. Next, we'll do the blue one. Pretty obvious that it's part of the pi over 4 family. Okay? Negative 5 pi over 4 is going to be in quadrant 2. Okay? Again, I would think, hey, 5 pi over 4 is on my pi plate. In the positive direction, 5 pi over 4 is in quadrant 3. So now if I'm going 3 quadrants in the negative direction, it's going to be in quadrant 2. Cos is negative in quadrant 2, and pi over 4 for cos is always root 2 over 2. So again, on your exam, they'll just look at this number. If you have the negative sign, they'll give you a half mark because you got the right quadrant. If you have the root 2 over 2, they'll give you a second half mark because you have the right ratio. And finally, tan of 23 pi over 6. Well, 23 pi over 6 is 3 5/6 pi. That's telling me quadrant 4. Tan of my pi over 6 family is root 3 over 3, and now because of the cast rule, it'll be negative root 3 over 3. They'll give you, this would be a 3-mark question. They'll give you 1 mark for the green answer, 1 mark for the blue answer, 1 mark for the purple answer. They give you no marks for writing your final answer, but if you get it wrong, they take off a half mark. So now we have to multiply this out. Maybe you'd be like, oh, my 2's would simplify. A negative times a negative is positive. Root 2 times root 3, that will be root 6. And on the bottom, I'll get root 6 over 3. as my final answer. These are not supposed to be hard questions, and yet historically, on the exam and on your quizzes, on your test, these ones where you have to do 3 of them, people start making up all sorts of new math. You don't know why, it's just a pie plate question. In fact, I color-coded it's a pie plate question 3 times in the same question. You have to find a value for one, you have to find a value for the second one, you have to find a value for the third one, and then you have to simplify. Okay? But these pie plate questions are complicated because you have to remember a whole bunch of stuff. You have to know what family is it, what quadrant is it, coterminal angles. All of that comes together in one question. So I have some practice questions for this as well. This assignment has, or this practice assignment has 4 parts. It's really the parts 1 and 2 I think are pretty easy. It's part 3 and 4 that gives you lots of practice with these questions. So if you want to skip ahead to part 3 and 4, so I would really turn to the back, part 3 and part 4. They have lots of questions like this. Some of them have squared stuff. So I want to just, if you had a question that said, what is tan squared of, what one should I use? Let's do, if I gave you tan squared of 16 pi over 3, how would you do this? Well, you would figure out what tan of 16 pi over 3 is, and if you have tan squared, whatever that is, you would square it. So off to the side, I'm going to figure out what tan of 16 pi over 3 is. Well, first of all, I hope you can see that your reference angle is your pi over 3 family. And 16 pi over 3, as a mixed fraction, would be 5 1/3. 5 1/3 tells me I'm in quadrant 3. I know that tan of pi over 3 is root 3, and I know in quadrant 3 it's positive. So this will become just root 3 squared. And root 3 times root 3 is equal to 3. So in part 3 and part 4, it has some squared values. Basically, you just find it without the squared and square it afterwards. That's what tan squared means, or co-squared means. So if you had something like this, you would figure it out first, and then square it. All right. So this is all using your circle, using coterminal angles, and really doing a lot of mental math with our unit circle. Next thing we do is we find angles without our calculator. Okay? If this question was in grade 10 math, you would use your calculator. And you would say, well, no, there wouldn't be a negative. In grade 10, you didn't involve any negatives. So in grade 10 math, you would just have a positive value there, and you would go to your calculator and do sine inverse, and your calculator would tell you the angle. Same thing in grade 11, but in grade 11 math, you would have this same question, but instead of having radians, you would have degrees. And you would use your calculator to find your reference angle, and then say, I know sine is negative in quadrants 3 and quadrants 4, and find it from there. In grade 12, if it's non-calculator, you have to recognize the ratio and ask, if sine is my y-coordinate on my unit circle, is my y-coordinate ever root 3 over 2? Yes. What family does that? Pi over 3, pi over 4, pi over 6. So the first thing you're going to do is you're going to say, what family do I have root 3 over 2 on my unit circle? And sine is my y-coordinate. Okay? Pi over 3. So sure enough, when I look at pi over 3, my y-coordinate is root 3 over 2. Okay? If my family is pi over 3, then which quadrants will I look for sine to be negative? I think of my CAS rule. And sine is negative in quadrants 3 and quadrants 4. What is your pi over 3 family member in quadrant 3? 4 pi over 3. What is your pi over 3 family in quadrant 4? 5 pi over 3. So this is how we can solve it without a calculator. Okay? Cos theta is -1 on your unit circle. Cos is which coordinate? X coordinate or Y coordinate? X. Cos is your X coordinate. Is your X coordinate ever -1? Yes. Axis family, it'd be right over here, right? What angle is that? 180 degrees or pi, but because the question is in radians, we answered in radians. And this is all you have to show. So it feels like you haven't shown very much work. Tan of theta is -1. First of all, think of quadrant 1. Is tan ever 1? What family? As soon as you find the family, you know your reference angle. Then tan is negative, so according to your CAS rule, you're looking in quadrant 2 and quadrant 4. So now we have to say, well, what pi over 4 family is in quadrant 2 and what pi over 4 family is in quadrant 4? And so your answer in quadrant 2 is 3 pi over 4. In quadrant 4 is 7 pi over 4. How's your mental math going? How's your head? It's okay? All right? If you have a question with one of the reciprocal ones, the first thing you'll do, secant is related to cos, so this is the same question. Solving when is secant theta equal to 2 is the same question as solving when is cos of theta equal to 1/2. Think of quadrant 1. Cos is your x-coordinate. Is your x-coordinate ever 1/2? What family is that? pi over 3. For doing the mental math, I find if you memorize one of them well, you can usually figure out from the one that you've memorized well, the other ones. So for example, I memorized sine of pi over 6 is 1/2. Then I would know that cos of pi over 6 is the root 3 over 2. That means that sine of pi over 3, it can't be the half, it has to be the root 3 over 2. Which means the cos of pi over 3 has to be the 1/2. So if I memorize one really well, I can usually use that as a check to figure out the other ones. So here, if I've memorized that sine of pi over 6 is 1/2, if I have cos as 1/2, I won't know it, well, it's not pi over 6. Therefore, it has to be the pi over 3. Okay? It's positive, according to your CAST rule. Cos is positive in quadrant 1 and quadrant 4. So it's going to be, quadrant 1 is going to be pi over 3. Then what is your pi over 3 family member in quadrant 4? 5 pi over 3. So at the very basic level, we're solving these without our calculator by recognizing the values from our pi. This one's a little bit harder because it started with secant, but it's the same as you can change it to the one that you know, which is cos. Next, we can have ones that are actually like mini equations. How hard would it be to get sine theta by itself? You'd have to move the 1 over and divide by 2. So are you okay to do that now in grade 12? We can do that in one step, I think. We could just write down -1 over 2. Okay? What family? This is where it's nice. I have the 1 memorized. Sine of pi over 6 is 1/2. I know right away that my family, or my reference angle, is pi over 6. Which quadrants am I going to look in? According to my CAST rule, here sine is negative. In quadrant 3, my pi over 6 family is 7 pi over 6. In quadrant 4, 11 pi over 6. Okay? So these will always be non-calculator questions, because they're values on your pi plate, and you have to be able to recognize them. And then, at another level, where you have to factor and solve. Quadratic equation. Oh, by the way, maybe I'll add one. You can still get these questions as calculator questions. So I'll add a calculator one just to remind us that we can still solve for questions that are calculator. I could have 3 sine theta minus plus 2 equals 0. And I would get sine theta by itself by moving the 2 over and dividing by 3. And then I would ask myself, is 2/3 one of the ones we labeled on our unit circle? It is not. This requires this to be a calculator question. As a calculator question, we find our reference angle by doing sine inverse This is a review of grade 11. In grade 11, you would do your reference angle by doing sine inverse, and it's always the positive value because reference angles are always positive. Okay, so I would go to my calculator and I would do sine inverse. Now in grade 11, you would have your calculator in degrees. And if I did second sine inverse of 2/3, I would find out that the reference angle is 41.8 degrees. But now we're in grade 12, it might be in radians. All we have to do is change our calculator to radians and type the same thing in, and it gives your answer in radians. So my reference angle would be 0.730. That's rounded to 3 decimal places. Usually we don't actually round our answers, so I'm gonna put the dot 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 that I'm gonna keep all my decimal places. Even though when I put the dot dot dot, I probably should write 29, the actual numbers, but they're only gonna check your final answers for round. So, according to your CAS rule, sign is negative. You're going to check quadrant 3 and 4. If you have a reference angle, again, you can draw a little picture. If I have it in quadrant 3, does it make sense that this angle would be pi plus your reference angle? I'm going to go to my calculator. Since I know that I'm going to be using my reference angle more than once, I really like the store button on my calculator. And right beside the alpha button, let's just store it as X. It doesn't affect any graphing, and it just replaces whatever you stored as X previously gets replaced. And so now I can do pi plus X instead of having to write all those decimals. 3.871. And in quadrant 4, can you see that here I would do 2 pi minus my reference angle, just like you would do 360 degrees minus my reference angle with my calculator. And this is where it's really nice that I've got it stored as X. I can just go minus X again. 5.553. So you're going to get some questions that are calculator, where you do everything the same as you did in grade 11, except your calculator's in radians instead of degrees. This is exactly how you would have done this in grade 11, but you would have been in degrees instead of radians. But if it is a question that's on your pie plate, it's a lot shorter, because you can find your reference angle right away by just seeing what family it's in. And then you can state your answers right away by just writing the family members that are in those quadrants.